A backwards tree question looks like a regular tree question. So here are two examples with the classic double forking situation for two stages. So let's pretend this tree question is about a survey. Question 1, question 2, question 1, question 2, and it's just a straight yes or no. Summaries as usual, recording everything that could possibly happen. Now, in a regular tree question, we give you information so that you can put probabilities on the branches, and you then do multiplications of fractions or decimals so that you get the figures on the summary. A backwards tree question does it the other way around. We give you information on the summary, and your job is to come up with the information on the branches. Okay, so I'll give you an example of that now. Okay, so let's say I tell you that, let's suppose I tell you first that 18% of people answered yes to both questions. Do not go and put 18 over 100 on the branches, put it on the summary. Let's say I next tell you that 28% of people answered yes to the second question. Now, it's very important that you understand that you cannot just go and put 28 over 100 there and 28 over 100 there, because you've seen this many times. Sometimes the figures there are different from the figures there. So what can you do? Well, you don't even have to write 28 anywhere. Just write 10 over 100 there. Why does that work? Because the elements of the summary with a y in second position now add up to 28. The next information I give you, the third and final piece of information, is that 75% of people answered yes to the first question. Now, you can put 75 over 100 there, okay? But experience tells me that for a backwards question, it'll be better if I write 3/4, okay? You'll see why in a second. So there's a difference between this unduplicated branching, where you can put figures direct, and these where you cannot, because you have to allow for the fact that they might be different. So, as well as putting that is 3/4, I could also go and put a 57 over 100 there, because it says the same thing. The two elements of the summary with a y in first position now add up to 75 over 100. Now we're good to go. We can basically answer the whole question. If that's a 3 and that's an 18, we can make it work by making that a 6, and if that's a 4 and that's 100, we can make it work by making that a 25. If that's 6 over 25, that has to be 19 over 25. If that's 3/4, this is 1/4. If that's a 1 and that's a 10, we can make this work by making this a 1. If that's a 4 and that's a 10, we can make this work by making that 25. If that's a 1, oh, wait on. If that's a 1 over 25, this is a 19 over 25. And if that's a 1 and that's a 19, and this has to be, oh, wait on, I don't know why I wrote that. If that's a 1 and that's a 10, this has to be a 10. So this has to be a 15. So 1 times 15 is 15. There we go, we're done. Now you can answer anything, all the usual questions. But just before I move on to another example, I'm just going to tell you about a very special sort of question where you can just read it straight out off the diagram. Where you don't actually have to do any work. And that unusual question is this. Given that the answer to the first question is yes, what is the probability that the answer to the second question is also yes? And the answer to that is just 6 over 25. Okay? So in other words, the word given sends you down one of the branches, so that's already certain, that's given to you. You don't need to worry about the 3/4, and now they're just asking you what figure is for yes. I'll give you another example. Given that you answer no to the first question, what's the probability you answer yes to the second? Well, the moment I say given that you answered no, just go down that branch, and then when I ask what's the probability that you answer yes for the second, just read that figure back to me. Okay, so that's how to handle questions which use the word given. Okay, they don't come up often, but they sometimes do come up. Okay, first piece of information. 40% of people have answered yes to the first question or the second question. Now that means that these 3 pink ones add up to 40%. Okay? Now there's no good way of writing that. You just have to use colour coding or whatever to show that that 40% covers all of them. The word or, remember, gives you 3 chances to agree with something, either because you agree with the first, or agree with the second, or agree with both. Okay? The next piece of information is that 25% of people answer yes to the first question, which I'll now indicate in purple. So those two add up to 25%. Okay, and remember, answering yes to the first question you can put straight onto the diagram. Experience tells me that 5 over 20 will be the best version of 25%. That'll become clear in a second. The final piece of information is that 30% of people answered yes to the second question. Okay, so in other words, these green ones they add up to 30%. Okay, now we've got enough information to complete the tree. If these pink ones add up to 40%, that has to be 60 over 100. Now, if that's 5 over 20, this is 15 over 20. Now, if that's a 15 and that's a 60, we can make this work by making that a 4. And if that's a 20 and that's a 100, we can make this work by making it a 5. If that's 4 over 5, that's 1 over 5. Now, if that's 5 and that 15 and that's 1, this will be 15. And if this is 20 and this is 5, that'll be 100. If the greens add up to 30, and one of them is 15 over 100, the other must be 15 over 100 as well, or else they wouldn't add up to 30. And therefore, because all 4 of these have to add up to 100, we can therefore say that that must be 10. Let's just check that this makes sense. If you add up the figure for the purples and the figure for the greens, you get 55%. But we know that the pinks add up to 40%. So there must be 15% worth of double counting, and that's the double counting there. So that makes sense. Okay? So now we just work backwards and everything. And now we're done. So if I say, what's the probability they answer no to both questions? Just read me that figure, 60 over 100. If I say, what's the probability that they answer, what's the probability that given they've answered yes to the first, they answer no to the second? Just go down that branch, ignore that figure, just go down that branch because I gave that to you as a given, and then just read that figure back to me. So in other words, the probability that you answer no to the second, given that you answered yes to the first, is just 2 over 5. It's sitting right there waiting for you to read.